In this video, we'll be looking at multiplication of complex numbers. To multiply complex numbers, multiply as with binomials using FOIL, meaning first, outer, inner, last. So our first example, we want to multiply the complex number 5 plus 3i times the complex number 2 minus 7i. So if we multiply our first terms, we have 5 times 2 is 10. Multiply our outer terms. 5 times negative 7i is negative 35i. Multiply our inner terms. 3i times 2 is 6i. And multiply our last terms. We have 3i times negative 7i is a negative 21i squared. Now there's a few things we can do here. We can combine like terms, and we know that the I squared is the same as negative 1 by definition. So this expression simplifies to 10, and then negative 35 plus 6 is a negative 29i. And then negative 21 times negative 1. So this is a positive 21. And we have 10 plus 21 is 31 minus 29i. Try another example. This time we have a complex monomial multiplied by a complex binomial. All we need to do now is distribute. 3i times 2 is 6i. And then 3i times 4i is 12i squared. Again, I squared is defined to be negative 1. So this expression is 6i plus 12 times negative 1. 12 times negative 1 is negative 12, and you usually write the real part first. So negative 12 plus 6i is our product. Another example. This time we have the complex number 4 minus 5i squared. Now we know that squaring a number means that we multiply it by itself. So I'm going to write this out. 4 minus 5i times 4 minus 5i. Now we can use FOIL on this. So 4 times 4 is 16. 4 times negative 5i is negative 20i. And then negative 5i times 4 is negative 20i. And negative 5i times negative 5i is a positive 25i squared. I squared is defined as negative 1. And we can combine these two terms. So we have 16. Negative 20i and negative 20i is negative 40i. This one is 25 times negative 1. So I have two real numbers that I can combine. This is 16 minus 25. When we combine those, we get negative 9, and then minus 40i. One more example. Let's just use FOIL on this. The thing we'll notice here is that these are conjugate binomials. We have 9 minus 8i times 9 plus 8i. So when we multiply, 9 times 9 is 81. 9 times 8i is 72i. And then negative 8i times 9 is negative 72i. And then negative 8i times positive 8i is negative 64i squared. Now the thing when you multiply conjugates, these two middle terms will always cancel out. See, we have a positive 72i and a minus 72i. So these will cancel. Also, I squared is defined as negative 1. So we have 81 minus 64 times negative 1. So this is actually then a positive 64 when we multiply this out. So we get 81 plus 64, and that'll give us 145. Now if we were told to write this in a plus bi form, we would write it as the real part first, 145, and then 0i.